Hey everyone, welcome. Sometimes a couple of features can totally change how you work. Today, we're going to dive into two absolute game changers in Snowflake that'll basically turn you into a data superhero. We're talking about mastering time travel and Git integration. So let's jump right in.
Okay, I want you to picture this. We've all been there, right? You run a query, you hit enter, and then that cold feeling washes over you. Your stomach just drops. You've made a huge mistake on a production table. What if, and I mean, what if you had a magic undo button for that moment?
Well, that's exactly what we're going to talk about.
So here's the game plan. First, we'll tackle that oops moment and show you how to turn back time. Then we'll shift gears and talk about getting your code under control, from total chaos to Git-powered harmony. By the end, you're going to walk away with two brand new superpowers. All right, first up, let's get into your ultimate safety net. We're calling it the undo button, but its official name in Snowflake is even cooler: time travel. I mean, this has to be the #1 nightmare for anyone working with data, right? You meant to update just one single row, but you forgot the where clause, and now you've updated millions. The panic is real. You're thinking, okay, this is going to take hours to fix, if I can even fix it at all. This right here, this is exactly the problem time travel was designed to solve. So what exactly is time travel? Well, it's a built-in feature that lets you, travel back in time to see your data as it looked in the past. It's kind of like a version control system, but for the data inside your tables. See, when you run an update or a delete, Snowflake is smart. It doesn't just nuke the old data. Nope, it hangs on to it for a little while just in case you need it. Okay, so how long is that little while? That's what we call the data retention period, and it depends on your Snowflake edition. If you're on standard, you get 1 day by default, but if you've got enterprise, you can crank that dial all the way up to 90 days. Now you're probably thinking, why not always use 90 days? Well, there's a catch: storage costs. The longer you keep that history, the more you'll pay. So it's a balance, right? Safety versus cost. And just so you know, after that period, the data goes into something called failsafe. And at that point, you can't get to it with time travel anymore. All right, here's a common thing that trips people up: how this retention period actually gets set. You have to think of it like a waterfall or a hierarchy. The table gets its setting from the schema it's in. The schema gets it from the database. So let's say you set your database to 90 days. Boom! Every table in there now has a 90-day retention period, unless you decide to set a different value on a specific schema or even an individual table. You can always override it further down the chain. So you're probably wondering, how do I actually use this thing? The best part is, it's so simple. The first step is figuring out when you need to go back to. You can do that in two main ways. You can use the 8T clause with a specific timestamp, or, and this is my favorite, it's so powerful, you can grab the query ID of that disastrous statement and use the before clause. And this is a really important distinction between at and before. Think of it like this. If you use at, you're looking at the data including the results of your transaction. It's the after picture. But if you use before, you're looking at the data from the exact moment right before that transaction even started. It's the before picture. So when you're in disaster recovery mode, 9 times out of 10, before is going to be your best friend. Let's make this super real. Check this out. With just one line of SQL, that's it. You can create a brand new table that is a perfect copy of your old table from the moment before everything went wrong. I mean, think about that. No complicated restore processes, no frantic calls to your DBA, just one simple command and you've literally saved the day. So why does all this matter? Look, time travel isn't just some neat party trick. It's a fundamental safety net for your data. It means that a simple human error doesn't have to turn into a day-long crisis. It cuts down on downtime. And beyond that, it's an amazing tool for auditing and seeing exactly how your data has changed. Okay, we've got our data safety net. Let's talk about superpower number 2. We're still on the theme of control and making things reliable, but now we're going to switch from talking about data to talking about code. Let's dive into Snowflake's native Git integration. I'm sure everyone here has seen this movie before, right? You're looking in a shared folder and you see Final Script SQL, then Final Script v2 SQL, and my personal favorite, Final Script v2 final use this one .sql. It's chaos. When you don't have one single source of truth, you're just begging for confusion and, worse, deploying the wrong code to production.
This is exactly the problem that Snowflake's Git integration solves. What it does is let you link a remote Git repo, from GitHub, GitLab, whatever you use, and basically sync it to a special kind of stage right inside Snowflake. Now you have this read-only copy of your entire repository, your single source of truth for code, living right next to your data.
And you know what? Getting this set up is surprisingly easy. It's really just 3 steps. First, you create a secret to keep your Git credentials safe. Second, you set up an API integration that tells Snowflake how to talk to Git. And finally, you create the Git repository object itself, which points to your repo. And that's pretty much it. You're ready to go. Once that's done, oh man, the doors just open up. You can run your SQL scripts directly from a specific branch in your repo. You can deploy your Snowpark Python code. You can even manage and run your Streamlit apps. Think about it. You could have scripts that automatically set up a brand new Snowflake account. It puts all of your code, all your assets, under one roof, all perfectly version controlled. And just look at how clean this is. With a single command, execute immediate from, you're running a script that lives in your main branch. What does this mean? It means your entire deployment process, your CI/CD pipeline, can now be triggered by just merging a pull request in Git. You merge the code, you tell Snowflake to pull the latest changes, and boom, your new code is live. So again, why is this such a big deal? Because it's bringing all the best practices from modern software engineering and DevOps right into the world of data. We're talking about real automation, deployments you can actually trust, and making it way, way easier for your whole team to work together without stepping on each other's toes. Okay, let's bring it all home. We've just talked about 2 incredible superpowers you can add to your Snowflake arsenal. So let's recap the big ideas here. First, you've got time travel. Think of it as your magical undo button, your data safety net. Second, you have Git integration. That's your bridge to get from total code chaos to controlled automated workflows. And when you put them together, you're talking about seriously reducing risk while letting your team move way faster and with a lot more confidence. So I'll just leave you with this one question. You've now seen what's possible. You've seen these 2 amazing features. The only thing left to decide is, which superpower are you going to activate first? Thanks so much for joining this explainer.